What's up, guys? Tim Halstead, the Drag Boss. Welcome to the channel for a live chat. So I appreciate you guys being here. I don't see anybody here, at least in the numerical counter, but it doesn't matter. We just keep going, and as the people show up, here we go. So I want to thank everybody for being here. We had a live chat last night, Darren and I did, with our membership. There's 11 people here now. Knowledge is power. We talked for about 2 hours and 44 minutes on that. It was a great time. You guys might, if you're really serious about cylinder heads, that kind of thing, that's something you may want to think about getting into. So I've been working with Tony Bischoff now for probably a couple years on this 427 Cleveland build. And it's been sitting for a while now because we were waiting for a few things, and now we're back in the game. So I talked to Tony on Tuesday. So I'm going to start putting some information and some pictures on this build. It's the Tim Meyer DragBoss block. It's 427 cubic inches with a horsepower goal of 850. So I think we can do that pretty well. I just wanted to show you guys the cam specs on it. People are always interested in the cam, and I said, you know what, I copied it, and I'm going to put it up here, and you can see what it is. So it's based on 904 lifters. The cam's lobe separation angle 113. It'll be in at a 111. The lobe lift is 550 with a 175 rocker ratio. 277, 292 at 050. So it's a pretty healthy cam. So it should do well. So stay tuned for that. We'll be bringing that in, and I think you're going to be pretty impressed with that. At least I know I will be. So if you guys been paying attention on the channel, I've been having Nick Bacallis from Bullet Racing Engines. He's been putting up some content for me, at least giving it to me, and I've been putting it on there. I put one video. He was doing some piston installation on LS head. He's now building a twin turbo small block Ford based on, I think it was a Shelby block. It's pretty serious. He just sent me pictures of the internals, and the cylinder heads are C3s that are all welded up. So I think you'll be getting into that. Larry Sullivan, who's with us now, he may even be on the live chat. We just picked up a 351 Cleveland 2-barrel, and we're going to put that together, rebuild that, DragBoss specs. And I don't know, we may raffle that off for guys, and I don't know. We don't know where that's going yet. Now, a couple people that are going to be here, I'm already booked up for next week, so pay attention and be here because there's a lot of good people coming up. The week of the 23rd or the 4th, one of those 2 days, McLeod Racing is going to be here. And we're going to talk clutches. Will Beatty, Mr. Clutch, is going to be here. We're going to go over the basics. We're going to talk about your application maybe, at least my application, that we're going to use it on the Izzy 69 Mustang. So pay attention with that. Now, on the 25th, I have Bear Dellinger right here. So she's a drifter. She does drifting and some other racing, motocross, all kinds of stuff. She's going to come on for a live chat, and she works with McLeod and does a lot of their social media stuff. So she's going to be a good person to talk with. On the 28th is John Calvert. So I'm going to talk with him on the 26th to confirm before I put a post up. But John Calvert is a wealth of information. I think you guys would really get some good tips from him on talking to him about Caltrax, since he developed them, and the monoleaf spring, since he used my car to develop it. So I think that'll be great. That's on the 28th. The 29th is Chad Spire. Chad's going to be on here. We're going to talk about his history, kind of like with Richard, and we're going to talk about cylinder head and cylinder head porting programs he's developed. And then I have a live chat with John Wilborn, where he's going to do my history, I guess, a biography. So wherever that's coming from, I don't know, but I say let's do it. So let's see who we have here now. Looking down here, we have some new guys. Thank you, guys. Justin, thanks for joining the membership. I appreciate you. Spiro, it's good to see you here. And what do we got here? DragBoss, 351 Cleveland. Yeah, thanks, Bill. Yep, that's me saying thanks to Bill Fioretti. Thank you, Bill. He dropped a note. He's not going to be here. Jeff Ott, good to see you here. He knows Richard. Don Dotter, he's in with us. Thank you. I appreciate that. And we know this guy, Charles. Good to see you here. Another pro on the go. Tim Miller, thank you. Terry Grove, another porter. Does a lot of iron stuff. Trey Rags, it's good to see you. Thank you so much. Everyone's saying hi to everybody. And look, who else is here? Joel, of course. get ready, Joel, because you're coming on the hot seat pretty soon. So let's see what it's like. Yeah, what's up, kid? It's good to see you too, George. So now that we're done with the introductions, let's get down to the meat and potatoes. So I'll kind of give you some information. The gentleman before you here is Richard Katterjohn. Now, I never even heard of really Richard Katterjohn until I started getting into this group of some of the, we'll say, the elite porters in the country and out of the country, because there's some guys from Australia there. So I met Richard there in this group that we have on Tuesdays, where it's kind of a roundtable type thing. So I talked to him there. I've seen him there. When I went to PRI, I hooked up with him on Thursday. And that's the first time I met him. And then we started talking. I'm like, Jesus, this guy, I don't know who this guy is. I mean, the way he talks and who he knows, you know, and we start talking about his history with Grumpy Jenkins and Lee Shepard and all this stuff. And then he started telling me what he does. And I'll tell you, I just started blowing, it blew me away. And I said, you know what, we got to get on a live chat because I think it's important. Because Richard, you're what, 73?
Yep.
Yep. So he's not a spring chicken yet, but he still acts like one. He's like Warren Johnson, works 12 hours a day, doesn't sleep, and he lives and breathes cylinder heads and racing engines. So I figured, what better place to come and share his history and see what we can learn from him, because he now uses my mantra, knowledge is power. So we'll kind of get some information from where you grew up. Indiana, Illinois, where?
Yeah, Boonville, Indiana.
Okay.
I lived in Illinois for about 13 years, somewhere right around, and then my family moved back to where we came from, Boonville.
Okay.
Yep.
Now, what we always think about, like when I got into racing, you know, I was 10 years old. And at that time, it was 1975. There was cars around my block, heavy stuff, heavy Super B. The guy had an LT1 Vet, because I can remember seeing the LT1 or something on the hood scoop, and it crashed down the street from where I live. We all went through the wreckage and took our pieces, you know, the road sign still in my backyard. But there were things that just clicked with me, you know. And in your case, what kind of work did your dad do? What was he involved with, Richard?
Well, my dad started out at Bucyrus, Erie as a designer, mechanical drafting, mechanical drawings.
Okay.
A friend of his went to work at Emerson Electric over in St. Louis and told my dad, you know, this is the place for you, much better money. You know, you would be much more suited to this. So I was pretty small when we moved from Boonville to St. Louis.
Okay.
And I think I was about 4. And my dad went to work for Emerson Electric in the air defense section, where that's all they worked on was surface to air missiles and things like that. And the thing that they were working on was called the Honest John surface to air missile. And he made that a reality. And
Honest John.
Yep.
From Katterjohn?
That's just what they named it, was the Honest John missile, probably because of my dad, but you know, he was the lead engineer on it.
Yeah.
And then the Air Force bought it and the Army bought it. And I guess that was a big deal. And McDonnell was across the street at Lambert Field, and he got a promotion and he went over to Lambert Field at McDonnell, and he was put in the F4 Phantom design team, which, if you know anything about that fighter, well, that was a piece back in its day.
Oh, yeah.
And I can remember him talking about people like Bob Little, who was the test pilot, and Paul Noescono, who was a ace fabricator and all that. And we moved from St. Louis to Belleville, and then we moved from Belleville to Collinsville, and we stayed there the rest of the time before we moved back here.
Okay.
A relation of mine worked at Alcoa and told my dad, he goes, you know, we need a good leading design mechanical engineer with your background. And because of the situation that was going on in that part of Illinois at the time, it wasn't really safe.
Okay.
And so 2 weeks after that phone call, we're moving back to Boonville, and he had owned a rent house, and we moved into that, and they were building a new high school. Actually, they were just finishing it up when we moved in, and the back side of the high school that faced the back side of our house.
Yeah.
In the end buildings, it was all adult education. And, it was different. The school was different here than where I was at in Collinsville. And they actually looked at the difference in the curriculums and moved me ahead, which I don't know whether that was good or bad or whatever.
Yeah.
But it was a lot different life here than it was in St. Louis. I mean, St. Louis, everything was so spread out, and if you lived out in the suburbs, then downtown was far away and all that kind of stuff, where in a small town, everything that you wanted to do, the lakes, the parks, everything was in pretty close.
Right.
And my grandparents live here on my mom and dad's side, both. And I used to come back in the summertime from about 9 years old on and spend the summer with either my Katterjohn grandparents or my Hart's grandparents.
Yep.
So my Katterjohn grandparents raised racehorses, and my Hart's grandparents, my grandfather worked for Peabody Coal Company, and my Uncle Bob did too. And, being around my two uncles who had hot cars, even though they were Fords, but they had Carcraft magazines and all that, and I got to reading those, and they were out, working on their cars and all that kind of stuff.
Yeah.
And it started, piquing my interest. And my uncle Bill worked in the parts department at the local Ford dealer, so there was always stuff going on that was automotive related. And then my grandfather, that was all big heavy equipment and things like that.
Sure.
So and everybody around here used to hunt and fish, and my Uncle David, who was a design engineer at IBM, when he would come back in the summertime, he'd always bring me a bag full of printed circuits and little servos and stuff like that. Here, they were going to throw this away. So, there was all these opportunities in front of me. And it's when you're really young, it's hard to know what direction to go. And you generally go where the adults go. So
yep.
It was different. And then when we moved back here and started meeting, I met kids my age that worked on the farms where they bought stuff in the local farm store and things like that. But it's because how everything was spread out. And my Hart's grandparents lived on Poplar Street and Scales Lake, which used to be an old strip mine, but it's a big lake and resort area, has a bicycle ride away. So, getting into the water. And, when I was a kid, I used to watch Sea Hunt and Sky King and, stuff like that. And it was just all stuff that I wanted to do. So, that was kind of the precursor.
Okay.
And one of the friends that I made in Boonville was Mike Durner, and his uncle, R.O. Woods, had a 55 Chevrolet small block gasser, straight axle, 3/4 ton rear end, with the arms on it and a tilt front end. And they used to do test and tune at Chandler, which was about 5 miles away, on Wednesday night. So Mike goes, we can go with you if you want to. Well, sure, I wanted to. So, we rode in the back of the pickup truck and went down there and got to see real race cars up close, and that was just, I was hooked. I mean, that was just what held my interest, among other things. And some of the older guys that lived on the same street that I did, they hunted and things like that. So, I ran with them too. So it was just, there was always so much going on and always something new to learn. And, it just, all these opportunities and all the people that I got to meet that I would listen to what they had to say, but it's just like living by the high school. Well, I knew what an arc was, and I could look at that end building and see that somebody's welding. So one evening, I took my dad's old welding helmet and went walking across the field and over there, and they were having adult education classes. And the guy that was putting it on also taught shop there. And he said, "What are you doing with that helmet?" I said, "I came over to watch." And he goes, "Where'd you get that?" I said, "From my dad. When he was in college, he used to weld in a place in Terre Haute that made stuff for the shipyards. And my grandmother was going to throw it out and gave it to me instead. So, here we go again. Now it's welding." And when I was in high school, when I attended there, they had automotive, they had welding, they had machine shop, they had all that. And, my counselor was going, "Well, but you're not on that path. You're on the academic path." And I'm going, "Yeah, but I really like to get to do this other stuff." And he goes, "It's too much for conflict of interest, blah, blah, blah." But again, they always had adult education, and knowing the shop teachers, well, we're going to do so-and-so tonight. And I can remember the year that I graduated, the welding shop got a brand new 500 amp Hobart CyberTig, water cooled, foot control. And some of the guys that were in there were pipe fitters. So they tigged all the time. And the first time I saw that being done, I'm going to learn how to do that. And, that took off on another path. And that's a skill that has served me well for many, many years. And the more I got into cars, 1970 to when I graduated to a little later in 1972, then U.S. Army. And after that, I worked on the sheriff's department in Warwick County, and I ran dive rescue because I had, again, being a water spaniel, being in the divers, there was a dive shop right in Chandler, Indiana that taught lessons in their big in-ground pool, and, ride my bicycle and go to it. And then as I got older and, got to do more, then that was just something else that I was able to do. But in my heart, it's always been about cars and engines and fabrication and curious. My nickname's KAT, so, I'm always curious. But there's so many people in this business that have been really good to me and helped educate me and worked with me. And I know so many people that were considered leaders, shakers, movers. And that's the kind of people that I always wanted to model myself after. And, I owe a big debt of thanks to all these people that helped me all these years that brought me to here. It took me 53 years roughly to get to where I am today. And I still learn. I still, look at different programs and things like that. I started, I think the first pass I made in a race car was in 1974. I had a 55 Chevrolet that the guy that moved in a subdivision over from me had a tool and die business. And that's another group of people that have helped me tremendously. And it's where I got my first do more grinder and my first set of old 300 horse heads, and, reading in magazines and, buying the hot rod books, the how-to books and all that. And just, it's a disease for which there is no cure. I can tell you that. And a lot of hard work, but the rewards can't be measured in monetary standards. You really can't. And the people that you get to know and get to work with, there's no amount of money that compares to that.
Now, so you raced your first race car, so to speak, was a 55 Chevy.
Yep.
Okay. So you're racing, like, I remember you saying something about the guy that He owned a Chevy dealership. Remember I said the guy that painted Bob Glidden's 78 Ford Fairmount worked at his place.
Don Kuntz worked for Albert Clark.
Clark, that's it. Yes.
Clark Chevrolet.
Chevrolet. Yeah.
Yep.
So, because I always heard that. I heard Bob's do an interview and saying, "Oh yeah, well the car was done in 90 days." And Albert Clark, I remember him saying, the guy that painted cars painted the Fairmont.
Well, he owned the Chevrolet dealership, and Don Kuntz ran the body shop. Don was Albert Clark's driver. And in the modified cars, the comp cars, the pro stock cars.
So he was a pro stock racer or owner, Albert Clark.
Oh, yeah. And I was at Bowling Green with the 55. We used to normally run Windy Hollow on Saturday nights and Chandler on Sundays. And once a month, Bowling Green had a deal for the modified cars.
Yep.
And I was down there. Of course, I saw Albert. They were still running the 63 split window Corvette. And they came over and were looking at the car. And then Albert goes, "How much clutch have you got in that car?" And I said, "Well, it's a CRC Borg and Beck. And this is what, I found and somebody else recommended to me." He goes, "You've got too much clutch in that car." He goes, "You shouldn't pick front wheels up when you're hitting fourth gear." And, at the time I just had a DZ 302 in it with the cross ram and 2.4s and a Muncie and all that in the car. And it was in various stages, but in 1975, I put a Dana and ladder bars. Another fella in town that was going to build a Camaro bought all this stuff and ended up remodeling his house or doing something. And I ended up buying the rear end and the ladder bars and the coilovers and, stuff like that. And Paul Lance, who lived out the road, was on a Mopar dealership sponsor car. He had a Hemi Cuda and he got a lot of stuff given to him. And I got my first set of drag slicks there and my first mechanical tack and a lot of the stuff that he got that he couldn't use and cans of fuel but back then you could go to the Sunoco dealer in town and get Sunoco 260 race gas right out of the pump.
Yeah.
And again, being at the track and seeing all the guys that were really hardcore racers that did a lot. But Albert helped me out a lot, got me a good set of tires. He made some recommendations and he asked me if I knew where Cayuga, Indiana was at. And I went, yeah. And he goes, "Christmas Eve, we have a big party at my shop." And I went, okay. And he goes, "You need to come up there." He goes, "There'll be a lot of people that that race that could probably help you out." And when I drove up there in the snow and he told me how to get there. His brother Stanley Clark owned oil rights and filling stations and things like that. But when I walked into Albert's shop and started recognizing people like the Rear Morrison guys and Larry Kopp, the fellow that owned Cam Dynamics, there were so many people that you read about, and all that, and got to meet them and talk to them. And Mark Heffington said, "Albert tells me you run small block modified stuff." And he goes, "How would you like to try out some camshafts?" I went, "Sure." Because at the time, all I could get was what the local parts store sold, which was Crane. And it was okay for no more than I knew.
Right.
But, reading all these stories about how modified got started and what everybody was doing and all the cylinder head work and all that. I mean, it was just, I don't think heroin would have been a bigger addiction than what this stuff was, because you couldn't get it out. I couldn't get it out of my head. And the more people I talked to, and the more people that I met, like some of the pipe fitters that were TIG welders that were helping people build cars. And in fall of 1977, I sold the 55 and had bought another 69 Camaro that had a DZ engine in it that had been hit in the right front. And, you know, back then Bob Duffy and SRD, because they were building Jenkins's cars, and, you know, Jack Trust and a lot of guys that were, you know, really the movers and shakers in modified and all that. And
did you know Grumpy?
I met him in 1969 at the U.S. Nationals, and he had put a Cal induction hood on that 69 Camaro and then put a scoop on top of that, and NHRA threw him out for it. So Steve Foss, whose dad used to work on sprint cars and stuff, and I went up there. Well, here's these guys out behind. He used to have Lou Olejnik used to build these transporter trucks that they drove up into.
Yeah.
And they're out behind that, and they've got a generator going, and his crew chief at the time was Dutch Ergang, and he's out here drilling rivets out of this hood scoop. And one of the other guys was going to go into the Chevrolet dealership in Indianapolis and get just a flat steel hood. And Jenkins is standing there chewing on his cigar, and I walked up and I said, "What are you doing?" He goes, "What does it look like we're doing?" "We're drilling out rivets." And anyway, you know, and if you knew anything about Jenkins, he was a man of few words, but he was an engineer. He was tremendously smart, but he had no time for small talk at all, you know. And anyway, he went walking off. So later on, I saw him up at his truck, and he said, "You want one of my cards?" And I went, "I sure do." And later on, when we went to trade shows and stuff like that, but I saw him again in '74, and you know, he had the Vega there then, and
Yep.
and there was all kinds of people, and I said, "Doesn't look like you have to drill any rivets out of the hood scoop this time." And he turned around and he goes, "I'd certainly hope not." He goes, "Now I know where I know you from." And, you know, I read Jenkins's books. Like I said, I got to talk to him, but if you were going to talk to Grumpy, it was not about what he did. It's what he's working on. And one of the things I said to him was, you know, "What do you work the hardest on?" And he goes, "Cylinder heads and airflow." He said, "That's the thing that takes the most work." And, you know, they were still using welded up cast iron heads then.
Oh, yeah.
You know, and all the stuff work they did to the manifolds. And SRD actually had a shop, in a body shop behind his place up in Malvern, Pennsylvania. And Scott and Walt Winnie, S&W, was a big factor in that, because they actually did a lot of the fab work on the very first Vega, which I think was 73. And, you know, here's somebody else who wrote books and, you know, had articles in magazines and everything else. And the last time that I got to talk to him was at PRI, and he was standing there looking at a magazine of some sort. And I shook hands with him and told him, he goes, "I know who you are." "Well, we're talking about Pro Stock." You know, I said, he goes, "It's always cylinder heads. It's always airflow. It's always compression. You know, then you just have to build cars that are strong enough to take whatever it is you're doing." And about that time, Dave Conley walked up to him and said, "How much for 2 engines for the year, maintenance included?" He goes, "Well, if you've got enough money," he goes, "it'll be about $750,000. And he said, you know, so then that conversation started off, and I thought, yeah, I'm not going to be in the middle of this, and walked away. But yeah, he was really something. I mean, if you knew anything about him, he had an opinion about everything, and he overthought and over-engineered everything. And the guys that were on his pit crew, and like the manufacturers that supplied him stuff, like Ed Hamburger and Steffi and all them.
Yeah.
You know, when I got to where I could go to national events with the Camaro, the first U.S. Nationals I went to was 1979, because the first year that I had the car, I wasn't eligible to go because I didn't have enough points.
Okay.
Going out in the manufacturer's row and walking around in between all the Compliminator and Pro Stock cars and all that, I mean, that was better than Disneyland for me. And I ran the Camaro. I changed it 2 or 3 times about the suspension. I went from a Dana and ladder bars to a 4-link and a Ford rear end, and helped it out a lot. Whether people know it or not, AFCO and Dynatech are also in Boonville, Indiana. And the fellow that was my crew chief, Eric Saffel, I got him a job there. He goes, if I could have any job in the world, that's where I'd want to be. And I said, you don't like building race cars and working on engines and all that? And he goes, it's not really my thing. He goes, I have 6 years of college. And he goes, I'd much rather work with, customer service and finances and all that. And I talked to Mark Bush, and he said, send him down here tomorrow. But that opened up another door to research and development and being involved in taking products forward and all that. And once the Trans Am was done, then that was probably the best car I ever built. But again, I talked to Gary Hansen. I talked to Roger Lamb. I talked to Rick Jones. I talked to several people that were Ed Quay, people that were building those kind of cars. And again, I sought out the best people that there was for Jack Davis at Hooker Headers. I mean, anybody that I had been introduced to along the way that had knowledge, that's where I went every time. And again, it was good to me and helped me, but I never lost the passion for cylinder heads and airflow. And back in 77, before I sold the 55, it was down to me and another local engine builder, Sam Jones, who had Jones Engineering in Washington, Indiana. He walked over, and Sam was kind of a slight man. And he said, how come you don't ever come up and see me? I said, because you never invite me. And I said, we're competitors and all that. He goes, your stuff's good, but we can make you way better. Needless to say, the following Monday, I drove up there. And, he goes, because I had seen stuff in the magazines, how they were preparing blocks and all that. Well, they were doing all that. And in 1977, I think he got the first flow bench of 110 that anybody had. And his son, Jeff Jones, was doing cylinder heads, lawnmowers, yard tractors, whatever. But Jeff Jones owns One Way Technologies up in Washington, Indiana. And Chris Grace combined with them after he left Weld Tech, and some more really, really good knowledge. The prototype heads that I have done along the way, took them up there to be digitized so they could have CNC programs.
Yeah.
Again, another wealth of information because they worked on so many different types of stuff. They were in tight with Brodex. I think 84 is when we got the first aluminum Pontiac cylinder heads, because up to that point it was all welded cast iron stuff. And it was Duffy's, who was someone else I met on the East Coast bunch, sold CHA stuff, and that was all welded cast iron heads, 492s, and then up through the 292s and 034 bow ties. But
let me ask you this. So the Pontiac heads, here's about what I know from Pontiac heads. The Ram Air series, Ram Air 1, 2, 3, 4. that's what you're talking about. That's what they were modifying. Those cylinder heads or
No,
stock castings.
No, these were cast aluminum cylinder heads for the NASCAR program.
Before that.
Oh, before that?
Yeah.
Well, Sam Jones ran a D-stroke 389 Pontiac.
Yep.
And there was a fellow over in Harrisburg, Illinois, that had a shop built in a hillside, and he had a big gas-fired furnace. And he was brazing up heads and all that. And Sam had him braze up a set of the cast iron heads. They built a sheet metal out of exhaust tubing, a sheet metal IR manifold with 2 dominators on it to run in that. And he ran that in his Firebird, 69 Firebird. And again, here's seeing cylinder head stuff. But the Pontiac cylinder heads, when they first came out with those, Ron Winterhoff had done a lot with those. And Ron's head service out of St. Louis.
Okay.
And even though the first Pontiac aluminum cylinder heads for the NASCAR engines were basically Chevrolets, were just Dash 8 Brodex. They were 195cc intake runners and D-shaped exhaust ports, and they turned out to not be big enough. And the guys were welding them up and rolling them over and changing all sorts of stuff in them. And then they came out with the second design 867, which in reality was a Dash 10 RI SPX. So it was raised runner, raised exhaust port, and lot bigger runners. And those would really make some power. And so, everybody in modified and comp was getting away from the cast iron heads and going to the aluminum stuff. And there was a lot more to work with. They had a lot more room to modify.
Yep.
Where, like me and a lot of other guys that ran 283 blocks and 327 blocks, you were limited to a 4-inch bore. So you really couldn't put big valves in them. And Ron, like I said, Ron Winterhoff was doing more with those. And the first time I saw a set that he did, then it, said, no more cast iron, not when we can move this kind of air. But like in the 3.905 bore 283s and 277s and, the little short stroke, short rod engines.
Yep.
You could only put a 2-inch 050 intake in them, where you had plenty of room to put a 2-100, but you couldn't in that bore.
Okay.
And that's before we started doing 4-inch stuff. That's before you could get, a 2.680, 2.700 stroke crank and all that. But, back to Bob Duffy again, he had BRC rods. He had pistons to fit the different heads. And, it was just, things were changing so rapidly, and you had to stay on top of it. But knowing the people that I knew helped me along, to make my program better. My first flow bench was a 110, and but still, it was better than wondering. You read all the stuff in the books and listen to the guys what they were doing, but you didn't really understand how much it helped, or if it helped at all, or what you did. And when I saw my first set of Jimmy Bell heads that were all brazed and rolled over, way different than the CHA stuff that Duffy had, and welded program 2 manifolds, all this stuff was working towards more and more airflow, more and more induction efficiency. And, everybody ran 660s. And then later on, we ran 660 center squirters with 850 base plates. And then people that started specializing in carburetors, that's all they did. And the first time that I saw a set of those redone, I think it was in 1984. I still had the Camaro, and there was a guy riding around in pits on a motor scooter, and that's what he did, was nothing but carburetors. And he said, I was standing up on the starting line. He said, how high were you when you left? I said, pretty close to 11. He said, the car was smooth. It didn't smoke and all that. And he was from Fuel Curb Engineering. He was the guy that did, and he said, how'd you learn how to do this stuff with the carburetors? And I said, you really want to know? And he goes, sure. I said, Jenkins's book. And he goes, well, that would be the one you'd want to read. But he said, Jenkins's stuff is more towards 331s, 355s, bigger stuff. And he goes, and they don't turn that kind of RPM, and their cars are lighter, so it's a lot different. And he said, I said, well, I have a set of spares that's identical to what's on here. And he took them all apart and he looked at them and he goes, well, I can tell you what to change and all that. And again, another dose of knowledge that helped me out. And I've just been fortunate to meet the right people and be in the right place at the right time to add to, what could be done. And the Trans Am was a real learning experience. Even though I had built cars similar, it wasn't for me. And the Camaro was, like I said, it was a SRD kit car, and it came with an instruction book that was about an inch thick, but it was still learning. And when I sold the 55 to build the Camaro, I used to get my gas cylinders at a place in Evansville, and I went down there one day to get cylinders, and they had 3 Miller TIG welders sitting out on the floor. Special, buy this and we'll throw in that. Well, again, compared to what I had and what I knew, that was the way to go. And that was another step forward in capabilities as far as being able to weld pans and manifolds and cylinder heads and whatever else you needed. And again, my friends that were in tool and die and pipe fitters and all that would come over and help me. And again, everything that I've been successful at through these years, it's because of all the help that I got from people that set me on the right path. And, it was, again, not telling me, but did you look at it this way? Did you think about this? You've got to think from the top of the carburetor all the way to the bottom of the oil pan and everything in between, because just because you have a good set of heads doesn't mean that you have the right camshaft or this, all that. And it's been such a steep learning curve, but again, thankful to have so much help. And I was able to get into different programs of, testing stuff and learning more and more about cylinder heads as they changed, and freshening engines that somebody else had built in that I competed with, believe it or not.
Yeah. And
again, the theme was common in all of the modified and comp engines. It was all about airflow and cylinder pressure and making the camshaft be compatible with how much air you could move. Well, once we got flow benches, we could do that a whole lot better. But back then, the people you talked to at the cam companies who had been working with all kinds of teams, not just drag racing.
Yeah.
Well, this cam right here, what cylinder heads do you have? How much compression? On and on and on and on. But, then it got to the point where you started having to do your own stuff because I want to go a different direction than, say, Bob Garris or Brad Buxton that was doing machine work, or Mike Ebley that was doing machine work, and had to learn more about that. But I gathered, I guess, notoriety, if you want to call it that, from people seeing what I did and walking over and looking at the car and talking to me. And when you start winning and you start setting national records and you know, really putting in the work, then people pay attention, and some help, some want you to do, you know, their stuff so they can be like you. And it's just, I don't think that it ever slows down. You know, all this thirst for knowledge has so much momentum. And you look at the big shops now, especially the NASCAR shops, the pro stock shops, the people that do all the comp eliminators, but now we have so much better cylinder heads and manifolds and stuff manufactured. Like CFE already has a set of 10-degree heads, you know, that you can buy from him to put on your comp eliminator motor, and he has a manifold that goes along with that, and a camshaft recommendation. And especially with all CNC and digitized stuff, this stuff goes forward really fast. You could have some of the best stuff there is, and a month later you're out of the fold. And that's really made it interesting. But, you know, R&D is nonstop moving forward if you want to be competitive. And it all goes back to a lot of the great people that I met and working with Superflow flow benches. And I met Harold Bettis at an ATEC conference one time, and he and I got along really well. Joel Allen DuBose, I met him. And again, another wealth of knowledge because he has done so much. Mm-hmm. And to still have him as a mentor and someone that I can talk to and work with, you know, it's just, it's amazing. You know, the cars are so much better. The engines are so much better because everybody keeps pushing forward, better, 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 better. And I would have never thought that the pro stock cars or the comp cars would run as fast as they do now. Cylinder heads and everything else is built around that, for the right piston, the right camshaft, the right manifold, the right header, and then everything in the periphery. But, you know, airflow is the trick. It doesn't make any difference how good the rest of it is. If you don't have the right amount of airflow and speed and it engineered for what you're going to do, it won't get any better. And then when you get into like summer when it's hot and humid, you know, that's a whole different ball game as far as air fuel ratio and leave RPM and all that. And but everybody that has access to all these predictive programs and all the people that have data gathering on their flow benches and DROs on their machinery, this stuff just keeps getting better and better and better.
You know, I'll tell you, it's funny when we talk here and I see some of the people on the sides here, because there's some questions that I want to address. But I lived in a world that's so narrow when it comes to cylinder heads. All I know is Darren Morgan, because that's the only person I've ever talked cylinder heads with that explains stuff to me. You know, that's it. But then after I met you, and then I met Joel, and then I start meeting other people that are in this group, I realized that it is a big world, but it's really actually small. There's only about, I don't know, maybe 10 people that could do the exact same thing when it comes to a cylinder head. Not just saying port, I'm saying design it from the ground up. It's not a huge, you know, business, so to speak. You know, anyone can take a grinder and grind a head, but knowing where to grind it, what to do, how the velocity works. You know, what guys did you, like one of my heroes, or I guess a hero, of course, you know, like Lee Shepard. You know, I'm a Ford guy, but when it comes to rear Morrison, maybe because Darren was there and it's the pro stock thing in me, I love those cars, man. You know, the stuff that they had, and to see the work that he did on those cylinder heads that were solid and they drilled holes to make water pass. Oh, yeah. And did you work with, and there's a guy here that's on, and maybe you guys don't know him. We got 69, 70 people on here. Adger Smith is a guy I talked to yesterday for 2 hours before his phone died, you know, and he's going to be on. He's a huge wealth of knowledge. All these guys are coming out of the woodwork for us so we can get their story. Like, did you ever meet Shepard, Lee Shepard?
At the races.
Okay.
At the races. I went out to Texas one time to a race very, very early in my career.
Yep.
82, 83. And all the guys that I had heard of,
Yep.
like Bill Staley and Jimmy Bell. In fact, I had several sets of Jimmy Bell heads that were passed down from another racer to learn from the welded cast iron stuff to the Pontiac heads and the, the Brodex Pontiac type heads.
Yeah.
And everybody that I ever talked to, and, Darren is one of my mentors and has been for a long time, every cylinder head person I ever knew all said the same three words. If they didn't say velocity, 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 they said airspeed, 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 and shape, and being application specific. Just because this cylinder head works on this engine doesn't mean it will work on that engine. And, it's just like when you're designing a port or you're going to do a prototype cylinder head for a specific engine. Well, you're going to have to look at, okay, it's this many cubic inches. They want to turn this many RPM. You've got to move so much air. All right. Then it comes back to how big does the port need to be? How big does the intake valve need to be? What are the restrictions on bore size? Is it splayed valve? Is it wedge head? Because all of that comes into play. And, but again, it comes down to how much air you can get in and get out, and how efficiently you do it is where you're going to make the power, the longevity, and the repeatability. Because in racing, if you don't have repeatability from round to round, even though the weather and stuff is changing, it's not going to get you where you need to go as far as, class cars and the pro stock cars. Everybody wants to be number one qualifier. And again, that comes back to how much air, and the cylinder head has to be specific to that combination. And I don't think there's anything that gets worked on more than cylinder heads and manifolds.
Yeah.
Maybe piston dome shape, maybe camshaft and all that. But as far as the real work of doing the prototypes, having them digitized, then cut in CNC so you can put the valve job in it that you want, go to the bench. Pitot tube never lies about as far as airspeed goes. And it's never ending. I mean, it is just never ending, because the advancements in technology, some of this stuff is from day to day. It's so fast. You look at all the places that have CNC machining centers,
mm-hmm.
whether they do blocks or heads or whatever. One-Way Technologies, they have all kinds of different CNC machines, and there's not a day that I've gone up there that all of them weren't working. And they had a CNC lathe to make seat rings specific to what they were doing in their R&D programs. But anywhere there's race engines, there's somebody that's doing cylinder heads, and there's somebody that's working on the induction system above it, and it's worked all the time.
If you think about, Pontiac, kind of go back to like the Pontiac, because I know you're more of a Pontiac kind of guy in development, like cast iron stuff, because a lot of the subscribers here, some of them have the old GTOs, or they have, stuff with like the Ram Air 3 head on it, the evolution of them. Like what's the difference between a Ram Air 2 and a Ram Air 3? Do you know that off the top of your head if I asked you that?
Well, some of them, it was combustion chamber shape.
Okay.
It was valve size. A lot of the Ram Airs, it's like the Ram Air 2 was a 400, and it has a block that's specific to it.
Got it.
All the factory stuff was all cast iron.
Yep.
And the guys that run super stock with that, they have to stay within what the rules say. You can do anything to that head you want to, but you have to have stock valve sizes, combustion chambers, intake runner volume, exhaust port volume, and there's a lot of welding and brazing and epoxy in those heads.
Yeah.
And then the 428s can use a specific Edelbrock head that can be worked to NHRA specifications.
Okay.
And be legal. And, aluminum heads, again, you're going to take 90 pounds out of the front end of that car, but you're not limited by a factory casting because, the factory's got to make 10,000 sets of heads, and the factory rates your horsepower 2,500 RPM, and
right.
The like the Ram Air 5 deal, that was to compete with the Fords because Fords had tunnel ports, and we come back to John DeLorean.
Yes.
When he was there, and
his brother actually got a set of the Ford tunnel ports and brought him to John and said, "Hey, make this head."
There's so much crossover in knowledge about what we all do. All the cylinder heads all have valves, they all have intakes, they all have exhausts.
Yep.
They all have different combustion chambers, and working those to get them as efficient as you can be. A lot of times in NHRA and IHRA, you're limited by what the rules tell you that you can do. And to me, the 428, which was an offshoot of 421s,
okay,
because it can have the Edelbrock head, is going to be leaps and bounds ahead of anything that's restricted. And again, there's a lot of work being done on those. A lot of machine work, a lot of welding, a lot of epoxy. It's not unusual for a set of fully prepped heads bears $10,000 because of all the work that it takes and all the time that it took to develop the port shapes,
sure,
short side radius, and the throat percentage and everything to be able to work with that combination. 15 years ago, you didn't see anybody turning Pontiacs 82, 83, 8,400 RPM. They do it now. Even we'll just call them, the Pontiacs that have Chevrolet stuff. But it, again, all these people that have worked so hard, and all of the gains is due to technology.
Mm-hmm.
If you can't measure, you can't quantify, and you don't know where to go from there. And like I said, a lot of these predictive programs, like PipeMax and IOP and Induction Logic Pro, you can put your specifications in there and it will get you so close. And those software developers put in a lot of time and a lot of work and to help us out to get to where we need to go. And there's just as much cylinder head development, whether it's sprint cars, open wheel modifieds, dirt cars, NASCAR, whatever. The biggest amount of R&D work is in cylinder heads and longevity. And the stuff now that's all, like I said, splayed valve, canted valve, which is ROX7 and the Toyotas and all that. Again, they all now Toyota started out with a splayed valve, canted valve head because they looked at what everybody else did and what they accomplished, so they could start from a specific place and save them time and money.
Sure.
And the SB2s and SB 2.2s, that all came from NASCAR. The aluminum Pontiac heads, they all came from NASCAR. And, Pontiac had a really, really good cylinder head program. And JV at Brodex listened to what was going on. There was a lot of cylinder heads being welded up and stuff moved around. And then they were sent to Brodex and machined, and then they made a core box out of them so they could move forward with that design. And again, now that they have CAD CAM and laser scanning and all that, again, the program moves forward faster. You can do more in a day than you could do in a month 2 years ago. And, that's what makes all this so fascinating. There's probably nobody that works harder developing cylinder heads and math than Darren. I mean, it's the programs that he has and the amount of knowledge that he shares with us is just unprecedented. And, I'm proud to call him a friend and a mentor because there's hardly any time that you can stump him because he's been doing this since he was 16 years old. He was grinding on pro stock heads when he was 16 years old in his father-in-law's shop.
Yep.
And outside of, parachute jumping and a few other things that he's done, his whole life has been about moving air and making cylinder heads specific to an application. Mm-hmm. And there's many, many people that are so involved in this that you can take the same piece of anything, have 5 people look at it, and you're going to get 5 different opinions, even though they all know what they're supposed to think about moving forward with or how to make this a better design, because all of us aren't linear thinkers. All of us have different experience. But again, safety in numbers, strength in numbers, and when we all work together, everybody does better. And again, everything is, we used to be concerned about quarter of a thousandths or half a thousandths in our machine work and concentricity in our valve jobs and all that kind of stuff. Well, all this new stuff, it can be down into tenths of thousandths and work within that confine and do it over and over and over again. So, there's some really, really intelligent people in this industry, and it's great for us because we're the end users. But a lot of the R&D was to take a particular product and make it better, more specific to the particular job it was going to do. Everybody says, oh, AI is going to replace us and, CNC, this, that, and the other. You still have to have somebody that thinks this out, that knows what it takes to do that particular job. And again, all the people that do all the engine machine work and cylinder head porters, to me, just like the professional engine machinist page or massive airflow, I mean, that is a whole gathering.
Think tank.
Yes, brain power.
Yeah.
Brain power. And everybody that's involved in this is a craftsman in their own right. And, I'm proud to be associated with groups like that.
Mm-hmm. We were talking about the ram air heads and then the Edelbrock stuff. Now, Bruce Culper here he had a comment, and I'm not sure. Well, I'll read it out and we'll see if we can make some sense out of it. So he says, Tim, Pontiac made a secret limited run of aluminum ram air Ford cheater heads. Jerry Steinbrick, who ran pro stock with a real Pontiac 455, saw a set on Naffel's DSA 70 GTO. Edelbrock made the first commercial. Know anything about that?
I don't.
Okay.
I know that there used to be some early pro stock cars that ran Pontiac engines. Bert Strauss had one, but in Canada that was an Astri instead of the Pontiac and all that. But if they made a run of ram air Ford cheater heads, again, I wouldn't have known anything about that because I wouldn't have been privy to that kind of information. Something like that would have been such a closely guarded secret because nobody wanted to get caught.
Right.
And it's again, that's why all this technology is so highly guarded. You know, but there's so many specialized shops that's all they do. Just like in Pro Stock, you know, look at how the cars have changed from what they were. You know, the Vegas in '74 were so far ahead of themselves, and then they ran the Camaros and then the Gen 3 Camaros and all that, because at the time the factories were so involved in this. You know, see it went on Sunday, buy it on Monday was what that's what their impetus was for doing that.
How about this one? I'll just put it up there. Walt says, regarding Pontiac heads, have you used 208 intake and 1.6 exhaust to increase velocity and CFM in iron and aluminum heads?
I can't say that I have, because the class legal stuff, you know, you have to use what came in it. And the other Pontiac heads, you know, the Brodex heads, you know, since we weren't limited, because in modified and comp eliminator, you're not limited. You can use whatever it is you can put your hands on. But if you were going to, you know, the Pontiac engines are not really high RPM engines. You look how long the rod is and everything, and rod length affects dwell time at the top and the bottom, and which affects airspeed and your mixture and all that. But if you were going to build, say, a street engine that you wanted better throttle response, because the airspeed would be more so, not that the Pontiac engines lack torque, because they have a ton of that.
Right.
And but yeah, a 2080 and a 1.6 compared to a 2110 and a 1773, it would definitely change the flow velocity in there. And the bad part about it is, on the size of the engine, now you're limited to the amount of RPM that you can turn because of the amount of volume that you can move through there. But again, airspeed, or velocity, however you want to look at it.
Yep.
But in a specific application, that would probably be a good idea.
There you go, Walt. Thank you. You know, one of the things I noticed about Pontiac engines is the cam is low compared to other engines. It's got a low cam, right, which makes long valve train and valve train stability. Do you see that?
Well, again, in what you're doing, because now we have roller lifters that are taller, but the cam sets low. If you look at how the valley is and where the cylinder heads are at as far as the deck height and stuff, that's one of the reasons it's down that low. And you know, and there's a lot of, in GM stuff, there's a lot of raised cam, you know, the decks, you know, we move the crankshaft center line and all that. And but the shorter you can make the valve train, the stiffer it is. And deflection is what eats up all of your really high end power. It sets up a harmonic in a spring, the amount of valve lash that you use, all that stuff has an influence. But like with the short deck Chevrolet blocks, like the Aurora blocks, you know, you're down to a pretty short push rod, and again, the stiffer it is, the less it transfers the harmonics, and the less flex you have. You know, so if you have 850 lift, but you lose 40 thousandths in deflection in the valve train, you know, you'd have to go back to the flow bench and see just how much you would lose in airflow. And harmonics are also very destructive in the valve train, which I know, you know, none of this is a big news flash.
Right.
But the shorter valve train and the stiffer it is, the easier it is to control, because you're controlling deflection and harmonics.
Do you see, though, like in these high-end engines, I mean, that's why they shorten the decks, the deck height.
Yes.
Shorter deck height is going to give you a shorter reciprocating parts, right?
Oh yeah, shorter rods, shorter pistons, and again, short deck block. You're looking at a different valve train, but anytime that you can put a shorter rod in it and pick up the airspeed, cut down on the dwell time at the top and the bottom, it's going to go faster. You know, the shorter rod is in the small block stuff, in the comp eliminator stuff, in the modified stuff is really helpful, especially, you know, we talk about the air being bad and heavy and all that kind of stuff. The more airspeed you have, the less that affects you, the easier it is to tune in those conditions. And again, the stiffer valve train will go more RPM with less damage and get there faster and cut down on the harmonics. You know, a long time ago, we had the only titanium valves we could get was like TRW, which was still okay stuff.
Yeah.
But as far as their sizes and stem lengths and lock grooves and all that, compared to what we have today, I mean, you can call 3 or 4 different valve manufacturers and get exactly what you want, how you want it done, as long as you're willing to pay the price. And there's several people that I have worked with in those positions that do a really, really good job. Their stuff, take it out of the box, and it's what you ordered.
Yep.
You know, and it will do everything you want done. And again, we look at the shape and what the face looks like, and the exhaust valve being more of a tulip, and we want the intake flatter, and now we have undercut stems and things like that. The margins, you can control the margins better. But all these people that make valves, they're the best of the best. Titanium actually came out of the aerospace program and fighter planes and all that kind of stuff, and trickled down to us. I mean, I've used titanium wrist pins before. You couldn't do that earlier because no coating and what they would do. Titanium's tough, but it's not hard. And there's been, I've seen dirt track engines with titanium rods in them, and that's all well and good because you can't use something like an aluminum rod or a really lightweight rod because they're on and off the throttle.
Yeah,
and they spin the tires. And the same thing in drag racing stuff. It's where it's under a load being compressed, and then it's under a load being stretched. And when you start changing the hysteresis of this, just like in a valve spring, now you're introducing a point of failure. And metallurgists have researched this and worked this. That's why we have all the different heat treats and all the coatings of different hardnesses and thicknesses that make the product better. I mean, to me, everything that can be coated, especially skirts and pins and coated bearings, all that, I mean, that is nothing but longevity. And a lot of the coatings are oil bearing, where you have a bearing that's just metal. Okay, that can be wiped off. The stuff that's absorbed into some of these coatings keeps that from happening. And the coating themselves, like piston coatings, they'll put a hard coat on the skirts at first, and then they'll put an abradable coating 8 or 10 thousandths thick, and it will adjust to the amount of load that is in that cylinder, and still help with oil retention and things like that, and keep that piston from scuffing. When it scuffs or a ring scuffs, now you've changed the crosshatch. Now you've changed the ring contact, the face of the ring contact to the cylinder. And again, cylinder pressure is one of the main ingredients of horsepower.
That's it.
And so we have longevity and repeatability by using these coatings. The aircraft industry was using the stuff 30 and 40 years ago. And even down to the paint that they used. And when that started spilling off into the race industry, then all of us gained. And there's again, all this research and development, it never slows down. you know, camshaft billets, what the rollers are made of on a roller lifter. You know, all that steel is analyzed, and they have different heat treats and coatings and all that. And again, it's about, if you don't finish, you can't win.
That's it.
That's all there is to it. If you don't get there first, you can't win.
Have you ever seen these heads? Don Dotter says the Mickey Thompson Hemi Pontiac heads. I think he was saying not many made. I've seen them before, you know, on some things. Have you seen them before?
Well, I saw them at a car show one time.
Yeah.
I think it was the World of Wheels up in Detroit at one time.
Yep.
And they had a lot of that. But, you know, there again, Mickey Thompson, forward thinker.
Damn, he was.
Knew of all the right people and manufacturers. And, you know, back in the day, California was the hotbed of hot rodding and manufacturers simply because of the climate.
Right.
You know, and a lot of the stuff that we have comes from aircraft manufacturers. You know, braided line. How many years have we had braided line, or, you know, stuff like that? That was all aircraft grade, and it's all about safety and repeatability. A lot of trickle down from the different manufacturers of what we're doing.
Thanks, Don. Terry Grover says, I saw a guy put a Pontiac Big Chief heads on a 540 cubic inch Chevy and slow down. He had the wrong combination because those heads were very good for their time.
Okay.
I don't know much about Big Chief heads.
Okay, a Big Chief head was a pro stock head.
Yep.
Terry, was it the 427 casting or the 386 casting or the 388 castings? Because that is a, you know, that's a 2400 intake and a pretty good size exhaust. And those were all made specifically for pro stock and A and B modified stuff. Yeah, I would say slowed down, because the amount of velocity loss that you would have on an engine no bigger than that, you know, you can't pump enough and pull enough air to make those effective. So yeah, those heads, I've done a few sets of those in DRC E1s that an all-out race engine is all that you could use it. And the thing, if the guy put the Pontiac Big Chiefs on there and didn't have good stable valve train where he could turn that up past 7 or 8 to be able to pump enough air, the amount of low end torque, even though it was a big block that you lost, and throttle response would be hard to recover from.
Jeff L. Ott says, Pontiac mains so large, bearing speed at high RPM. I don't even know how big Pontiac mains are. How big are they?
Well, they're bigger than they should be. A lot of stuff, a lot of the aftermarket Pontiac race blocks, like Lynn McCarty has, the IAs, the 10 Indians and all that, you can get those with LS mains, and you can also move where the thrust bearing is at. And the bearing speed at high RPM was another reason that the Pontiac, even though the cranks were nodular in the 4-speed cars, they failed because of that surface speed and, you know, shearing the oil barrier.
Okay. See, I never knew that. You're saying the old school Pontiac stuff with a 4-speed had nodular crank.
Yep, they did. A lot of them did. And of course, nodular is just cast steel instead of cast iron. But a lot of the Pontiacs that failed because they lost a bearing first because of the surface speed and shear the oil film, you know, and then when you put a 4-speed behind it and it knocked the tires off and, you know, all that, you know, that all goes right back up the drive line again.
Yep. Here's an interesting question. I don't know, you're a pretty good metallurgist, so you may be able to spit this one out, Richard. It says here, what's the difference between titanium and tool steel?
Well, there's a lot of difference because titanium is a non-ferrous alloy, and tool steel is real tool steel is forged, heat treated, and then coated. Titanium, because it's a non-ferrous metal, is handled a lot like how aluminum or any other non-ferrous. Yeah, there's a big difference. Titanium is light, and that's one of its biggest advantages tool steel is tough, and the whole, oh yeah, titanium is way softer. That's why you've got to run beryllium copper seats, and you've got to run hardened tips on it. Now they have a lot of these manufacturers have a really good hard coat on them anymore. Ferrea and Del West and a few of the others have a hard coat on that valve, and it works really, really well. But when you talk about any type of metal, the ability to be flexed and return to its original state, just like a valve spring, we're talking about hysteresis. Okay, tool steel is hard, it's tough, but when you get it to the Rockwell point where it's hard and tough, it also makes it more susceptible to flex problems. Yep. Damaging it. Where if you bend titanium, you bend it. There's no recovery. But as far as being lightweight and proper coating on it, yeah, titanium has helped the whole industry all the way across, because again, less rotating and reciprocating weight equals more horsepower.
That's it, baby. Edgar Smith says, Tim, the CNC evolution in our industry started when the aircraft industry took a dump a few decades ago. All the CNC shops doing aircraft needed customers.
Absolutely correct. Again, another carryover from the quality that had to be in aircraft.
Sure.
As they moved forward and used more materials like carbon fiber and things like that, that changed the aircraft industry too. And yeah, this aircraft industry probably ushered in the CNC machines because of the repeatability and the accuracy every time. Well, again, people that want the best will spend the money for the best, and the initial investment might be large, but down the road you're going to get a return on your money and then some, because of the number of parts and how good the quality control is.
Mm-hmm. You got to wait till you see this one. Joel says, to my knowledge, Kenny Weld was probably the first to do CNC work on heads for port work, learned in prison.
Well, I know a lot about Kenny Weld and what he did as far as port work and all that. Yeah. I didn't know that he did it in prison. I didn't know that they had CNC machines in prison, but anything's possible.
Well, don't they make license plates out of CNC?
That's stamping. That's stamping.
And Bruce says here, Smokey Unick told me when I asked him how he made Fireball Roberts 421 last for 500 miles, his answer was, the first thing I did was get rid of that goddamn big-ass main bearing.
And he did, too. And he did. Smokey knew a lot about that. And
did you ever meet him?
No, I heard him talk once.
Okay.
I was down at Daytona, and this has been a long, long time ago, and he was standing talking to some people, and if you listened to him talk, you had to really listen because of, if he didn't have a pipe, if he, he didn't talk very loud. I probably did when he got older, but, he was another one, to the point, always had a story, he was so smart. But again, it's forward-thinking people. Look at the stuff that he got caught doing, like a 15 extra feet fuel line so they could run more laps, and not run out. And he worked within the rules. He did. And he was just forward-thinking, because the whole point of racing is winning, regardless. So the one that's left standing is the one but some of these guys were such forward thinkers. I don't know how they ever got any sleep if they were laying there at night thinking of stuff, because all of us, you get a little thought in your head and then your mind takes off and it's working all these different scenarios and what if and all that. At least that's how it was for me. And, you know, and it might be something simple that you looked at the day before and think, now, wait a minute, if I did this, you know, that's why flow benches were so great in research and development, because you already knew what the demand was. You already knew the RPM you wanted to turn. And then we got into one of the most important things was port shape. So how homogeneous the fuel was kept. The fuel was in suspension, and how it went across the short side radius and all that. All of that is port shape. In splayed valve, canted valve stuff, it's a lot easier to do because you have more room and your valve is already canted. And like I said, the valve's open towards the center of the bore, so you can use better, you know, bigger valves, steeper angles. And, you know, unfortunately, you know, there's still a lot of classes and factory classes that wedge heads, there's all there is for you. But again, all these advancements, but it took somebody somewhere to think it up and test it out before it became common. That's why, you know, if you go to a NASCAR shop, you're only going to see certain stuff.
Right.
And the friends that I've had there and talked to, and some of the engine builders and stuff that I knew, you know, they'll only tell you so much. But fortunately, they told me enough to carry on that train of thought to know what they were doing. And a lot of them, that a lot of them now that don't do NASCAR stuff, they do land speed record stuff.
Okay.
You know, and like Duttweiler and all of them that I mean, they absolutely committed to this stuff. And again, land speed record stuff, we're back to aircraft quality and lightweight materials that will stand the pressure. Because I'm sure, like on the streamliners and all that are running 480, 540, 550, there's a lot of strain on that, especially in the drive line, you know, and that doesn't take much of a boo-boo to put you in a box.
Right. Darren was telling me last night, we were talking about development and stuff, and he was saying that with Lee Shepard, one of the things that he would do, you know, they take a cylinder head and they bring the short turn down and test it and see what it does. That's back in the day. That's how they found out. Then they would put it back, or they get another cylinder head, leave that alone, and change the roof of the port.
Yep.
Change it that way. Test it and see what it does. Write it down. Then they get another set of. I mean, they did a ton of dyno work and testing to see what changes would happen, you know, and then they extrapolate it out. Well, if it happened in this cylinder head, it's probably going to happen in this style, you know, and you kind of make that groundwork, lay that groundwork.
Well, a lot of what they learned running the small block engines in modified,
Yep.
You know, airspeed, airflow always follows a particular path. And the truths about port shape and length and short set, that transfers to everything that you do, regardless of the cylinder head. They all need and want the same thing to achieve similar results. And again, the stuff that's been done over the last 5 years, as far as airflow and port shape and all the equipment, just like cutting seat angles and being able to cut seat angles with a single insert. That new one, I mean, that is so. Now, everybody thinks that's really new stuff. They've probably been around 20 years or probably more. But think of the engineer, the forward thinking that it took to take something like that and make it better. And just like all of the inserts, you know, all of us started, or I did, with stones, you know, and everybody used 30, 45, 60. Well, then we got to thinking, okay, what if we made this a little steeper and the top cut a little bit wider? Mm-hmm. That's where all your flow bench work came in. because there was always something to be found. Step headers, that addresses airspeed, but also as that exhaust pulse, which looks like a smoke ring, it comes out of, say, the engine 7/8 and it's going really fast. Now it expands into the 2-inch, but at overlap, it can't pull that back up through the smaller tube. And then we get into merge collectors, which really pick up the scavenge. You know, now you're going to change your timing and your fuel requirements. Every little change that you make affects a whole train of parts, just like in the valve train. But everything you do to get the air in and out faster, you're going to make power. And it's the camshaft designers. They used to grind to predict, okay, what if you've got a low compression like a 9.2? All right, now we're going to manipulate valve opening and closing points. So we can build up the most cylinder pressure that we can before we let it go. And keeping the harmonics out of the valve train. But when you have a specific engine working in a specific RPM range that will move so much air, because we know what the induction system will do. And if you can give a cam grinder all those points about what it is, he can make you a camshaft that will do everything that you want it to do. It might take a couple of times, or change the center line, or change the rocker arm ratio, but at least you have a place to start to work from, and you'll know in a pretty big hurry whether it's better or not. And again, this stuff goes on 24/7, 365 in engine shops all over the country. And again, 5 different cam grinders look at the same thing and all have a different approach to how they're going to make this better, solve this problem, whatever. And none of them are wrong. It's just a different approach. And again, this whole thing that we do, from the carburetors to the oil pans to the collectors, this is a consortium. This is brain trusts all working together to solve a common problem. And again, it comes back to Yannick and Jenkins and all those guys, Lee Shepard. They looked at everything that they could control, bigger, smaller, whatever it was that they could change, but everybody knew the same thing. Cylinder pressure and airflow and longevity is what wins races and sets records, you know, and allows you to be #1 qualifier, unless you don't want to be. You know, but again, this is so ongoing, and the people that move forward with this, their determination, and you run out. If you're looking for more airflow and a specific application, whatever casting you start with, you're going to make a lot of changes to it. And 9 times out of 10, you're either going to run out of room, or you started with too much room in the first place, and you know your cross-sectional area and your airspeed suffer. You know, and again, we've got to make torque before we make horsepower, because you can measure torque, you can't measure horsepower without torque. And the amount of where that engine starts making its torque all has to do with what job it's going to do, with what transmission, with what weight car. It's like small cubic inch stick cars that work up in the 11 and 12 range. Those little engines don't have any torque. That's why we have such steep gear ratios and all that, and turn the kind of RPM. But in those engines, you better have airspeed that is relative to the amount of cubic inches that you're going to do. Again, the wrong cylinder head will kill the best short block that there is, or make the best manifold and carburetor look like junk, because it comes back to, again, airspeed, fuel quality. You can move a lot of fuel, but if it's not mixed with air, it won't do anything except get blown out the headers and wash your rings out.
What do you think about, you know, this is an expensive thing for a lot of racers that want to try to pick up something, you know, and I've learned, I think in my case, merge collectors were key for me. You know, I ended up with Cone Engineering 70 degree. which definitely seem to help on the low end. What's your thoughts? Are merge collectors worth the money? Clip it.
Every bit of, depending on what it is that you want to do. I can say that every engine that I have put merge collectors on have picked up, because let's say an alcohol car, fuel volume, they need help in the scavenge. Step headers and merge collectors have solved a lot of problems for racers, because it allows us to, there again, more air in, more air out. Scavenge is just as important as, the intake stroke.
Sure.
Again, if you would take a merge collector that's on an engine that's got the wrong camshaft, all of a sudden now you're too lean because you over scavenged. And again, everything is a system, from the top of the induction system to the end of the collector, and it all has to work together. But I haven't seen too many engines that they knew they were going to use step headers and merge collectors and had the right cam that didn't pick up, especially in different amounts of barometric pressure and humidity. Again, you can put it into over scavenge if you've got the wrong setup that it's attached to. But again, when Dynatech started doing this right down the road, they would make up prototypes, and I would take them to the track or put them on different cars and find out what was going on. But in my small cubic inch high RPM stick cars, step headers and merge collectors were, a real savings of wasted energy. The first set of step headers I ever got, I got from Jack Davis, that used to work at Hooker Headers.
Okay.
And then his two sons, they were good fabricators. They were smart. But anybody that worked in exhaust knew that, again, velocity, velocity, velocity. And anytime you pull more exhaust out, as long as you're good on your stoichiometric ratio of fuel, you're going to go faster. They're worth every cent that they cost, just like R&D is worth every cent that you spend. I mean, there's probably teams that would pay $1 million, if not more, for a 10th in a mile and a half an hour.
Oh, yeah.
Easily.
Mm-hmm.
Because you eventually come to the end of a particular part of how much you can modify it, how light you can make it, whatever the lengths are. There's so many different combinations of engines in use. You've got to work with everybody in the periphery to, when you say, okay, I'm going to move this much air, I'm going to make this much power. Then you start looking at induction, exhaust, lightweight cranks, knife edge, anything that you can do to cut down on windage. Anytime that you have an internal loss, how much horsepower does that internal loss take away from you? Turbos are pretty interesting, because there's no loss there where, like, the blowers on the funny cars and all that, you look at how many hundred or how many thousand horsepower it takes to twist that blower, or screw blower, roots, whatever it is.
Yeah.
And there again, we go back to diesels. Diesels had superchargers on them. All the Detroits had superchargers and turbochargers, so some forward-thinking individual go, oh, artificial atmosphere. We don't have to worry about this. And, it's being used in racing all over. I think probably the most work is done in the F1 series, in the road race series, because of the RPM they turn, the amount of power that they have to make, and the longevity that they have to have. I would say $1 million a day probably wouldn't touch some of the R&D programs going on in Grand Prix, in F1, all that, because again, the amount of winning is directly proportionate to how much you're willing to spend.
Yeah.
You know, and Jenkins used to say that speed is money. How much money do you have to spend? Yannick probably said it too. I'm sure Bo Laws, everybody that's been involved with any type of racing.
Sure.
And you look at you talking about clutches.
Mm-hmm.
Clutches in a stick car makes you or breaks you, and the clutches now are so much better and so adjustable and rebuildable. And again, I was lucky enough that some of the stuff I started out with that I bought over the counter, once I talked to somebody like Albert Clark, oh no, we don't use that much. We use this particular clutch, we use this particular clutch disc, and then all the miniature multi-disc clutches, like a lot of the comp eliminator clutches were 6.5 or 7 inches in diameter, and 2 of them, the amount of weight that you take out of the drivetrain right there. It all matters, but you have to have enough clutch that used to that you did it with all spring pressure and a little bit of centrifugal. Now most of it is all centrifugal, which makes it so much more tunable. And instead of 3 fingers, we have 8 or 6. And the tunability that's there, where the track changes in between rounds, you go download your race pack and you look at that driveline trace and determine what was going on. Even if you win, you still have to look at the combination that you used to get there, because in an hour later, when you go back to the lanes, how much has the air changed? How much has the track changed? Did anybody crash? Did anybody oil the track down? And again, repeatability.
Mm-hmm.
Repeatability.
One of the things you had sent me, and I think we should put it up because it's amazing when I saw this. Let me get the right picture up here, and then you can kind of talk about it. We'll start with this tunnel ram.
Well,
I never seen so much damn welding on a tunnel ram.
Well, part of that is when we started getting cylinder heads with raised runners in them, there's about 1 inch of weld on that. And then, of course, you epoxy the floor in, and then there's stuffing plates along the edge of the gasket surface, because you've got the cylinder heads rolled over so far, and the deck, and all that. But that's what that was doing, was when we got the raised runner Pontiac head.
Yep.
Then that was necessary to be able to do that, because sheet metal manifolds, even though they're common now, weren't back then, and there was sanctioning bodies and classes where you couldn't use that. You had to use a Pro-Ram 2 or a Pro Dominator. And I mean, you even go back and look at the Pro Stock manifolds back when they first got aluminum heads and using cast manifolds, how much welding and stuff there was on there. But that's 1 inch of weld, plus you had to preheat it, post-heat it, otherwise it'd have been so soft you couldn't do anything with it.
Okay.
But on the 277 or 287 that was on, was that's what needed to be done if you were going to use this cylinder head. Now
Like
that is taking a casting and adding metal to the deck and to the intake surface. That would go back to, we'll just say, Brodex, and they would machine that and make all the changes, and then make a core box to raise the runners, change the valve angle, change the combustion chamber. Oh yeah, that's what that was all about. And so again, we're raising runners, making smaller combustion chambers, and it gave them the room to do that, because you can't just make a core box out of, pull the stuff out of the air. You got to be able to have the prototype of what you're going to cast, and that's what that was all about.
So what head is that? Prototype for what head?
That was, I think one of them is a Pontiac. I think one of them is a Chevrolet bow tie head.
Okay.
But it was the whole thing was about raising the runners.
Yep.
And putting more metal on the face of the intake. So when you roll the cylinder head over, change it again. It was about changing the valve angle, smaller combustion chambers, lengthening the intake runner face. And there again, that's about 10.5 pounds worth of rod right there. And because that was the chamber shape that they wanted when it was done, you know.
Yeah.
Very, very little quench area in it. However many cc's they wanted to, but there was so much of that stuff when they came out with aluminum heads, and everybody was scrambling to make them better, and certain teams wanted certain things. That's what that was about.
Okay.
Now there was all that stuff was so hush hush and closely guarded, but this many years later, you know, that stuff's not done anymore because it's done on CAD CAM.
Exactly.
And all that, but that's all that was making changes to a particular cylinder head casting for a particular sanctioning body, let's say.
So it wasn't just rubbing the core boxes.
Mm-mm.
I mean, it was this.
Now that's
the core boxes.
Yeah, that's what that was about.
Wow.
And you know, that was when, again, that's all about changing the valve angle, smaller combustion chamber, raised runner, all that.
Now, what's this?
Okay. That's a super stock Pontiac head.
Okay.
And again, when you can do anything that you need to do to it, so there's a lot of epoxy and there's a lot of probably brazing, and because if you could see the exhaust ports on these,
yep,
they were a big oval. Well, those were brazed and raised up and turned into D's, so you would be able to raise the exhaust port and still stay within whatever the CC limit was on that. You know, because you're still going to be using the factory valve size, and you still have to have the factory CCs in the combustion chamber, the intake, and the exhaust. And like I said, you were allowed to do whatever, and that's what that's all about. And airspeed, pick that runner up, change that short side radius, how the apex blended into the back side of the seat ring, all of that.
In your opinion, what do you think is better for an exhaust port, round or D-shaped? And can you expound on if it's a D-shaped? Like, why is it better than round?
Well,
shape.
Again, if you're talking about a particular cylinder head, it was back then, it was whatever the manufacturer wanted, because they were going to have to make cast iron exhaust manifolds. And, you know, Ford had a lot of oval shaped exhaust ports. Ford had square exhaust ports.
Yep.
But in the racing world, when we can have anything that we want, it all depends on how much volume that you need. You know, that will come back and determine the port shape, because whatever your header is going to be, the D-shaped port is actually faster as far as I'm concerned.
Okay.
Because again, the flat floor and the short side radius and the transition over the apex, you know, the shorter floor, the difference in the length of the roof and the shorter floor has a lot to do with how it's handled, because exhaust is a pulse. You know, there again, we've got this smoke ring and we want it to expand to the ID of that header pipe and not lose velocity. It needs to carry all the way out to the end.
Yes.
So each pulse pulls the next pulse. And, you know, pulse tuning, another thing that's used in headers. So again, the amount of scavenge in a header has a lot to do. The cylinder head kind of determines what you're going to do. But again, we brazed in the different shapes because we wanted scavenge, we wanted airspeed, and it didn't make any difference where we'll say the exhaust port has a 1.773 exhaust in it, but it can only be 179 cc's. Yep. Okay, it doesn't tell you where you're going to, just as long as it's 179 cc's. And I'm going to go up every chance I get. You know, I'm going to raise the exit angle. If you say, look at the bolt-on port plates,
yeah,
and the header adapters, all that is doing is raising where everything happens, being able to put a different tube on there without bolts being in the way. You know, when we go to port plates, then we can move the bolts out farther in the header flange and not be bothered by what we're doing, tube size and everything else. Yeah. And you know, it made it a whole lot better when we were able to do that. And then you've got spread ports. Brodex has a spread port. There are a lot of cylinder heads that, you know, just small block Chevrolet, Pontiac, you know, it's a Siamese port. Yeah. But, you know, you can move those out farther when you don't have to worry about where the headers are going to bolt on or the size of the primary tube that you're working with. It's not dictated by the factory bolt holes.
Did you think Pontiac cylinder heads with the exhaust ports, the way they kind of swept down, was that detrimental?
Well, again, you're looking at a production cylinder head.
Right. To fit.
And it was about driving on the street. Mm-hmm. But when they did their horsepower ratings was a 2,500 RPM was the SAE, is where everything was measured at. So even though Pontiacs had a lot of torque, they had a big long rod in them that, again, dwelled at the bottom and dwelled at the top. And the shape of the port, the length of the port was made to work with their camshaft where the torque curve was at. Okay. Exhaust tuning is a lot about where the torque curve is at. Where race car stuff, we are pulling as much as we can because we're going to go across the finish line 10, 9, or 11. You know, you've got to still be pulling exhaust. Otherwise, the efficiency in your induction system falls off and you have puddling fuel. You can't light a puddle of fuel. You light a fog.
That's it.
You know, again, back to your stoichiometric ratio of your air to fuel ratio. That's why everybody looks at cylinder pressure and what, again, the stoich that they're looking at to do their tuning, because we know how much fuel we can put in. We want to see how much we can burn effectively and scavenge the trash.
Right. I found this kind of interesting too. I'll read the question and then I'll put the answer that Adger already answered. So okay. I didn't know this. It says, Jacob says, what's up with Pontiac making pro stock heads for big block Chevrolet? Did Pontiac have better R&D and better engineers? And I'm thinking, I don't know that. You know, I'd have to think about that. And then Adger Smith says, Pontiac was just the name of the head, aftermarket. Lee Shepard, Dick Maskins, etc., developed the big block Pontiac pro stock head.
Right, because it's still a GM product.
Right.
Just a different badge. So we'll call them the Pontiac pro stockers. Yep. They were still using GM blocks. You know, GM is corporate, whether it's Pontiac, Oldsmobile, Chevrolet, Buick, right. Whatever it is, that was all considered corporate. But putting race cars out, you know, that's why NASCAR had all the different brands. Again, see it win on Sunday, go buy it on Monday. But that was part of it. But Brodex did the majority of the Big Chief Pontiac heads. You know, Dart had their particular cylinder head. Mm-hmm. But back in those days, badging was a big deal that GM could have Chevrolet
Yep.
and Pontiac, where Ford just had Ford, Dodge just had Dodge. That increased the number of entrants in cars. Same way in NASCAR. The more cars you have out there, the better your chance is to win.
Okay.
I've like I said, I've done some of those, and those castings, the 427s and the 386s and 388s, they took a lot of work, and they took welding and epoxy to make them do what they were supposed to do. But again, because they were so tall, like the exit angle on the exhaust, short side radius, again, you're bending air, but it was a whole lot easier to do on the exhaust because you had so much cylinder pressure, but you still had to bend it and make it go out. Again, the upward angle in the exhaust port raised the roof, and you also raise the floor. Well, when you raise the floor, you're lengthening it too. And so the hot gases had a better tendency to stick to the apex, and it scavenged a whole lot better. And a particular cylinder head that I did the R&D work on, everything in it got changed because I had a clean slate of paper other than the outside portion and where the valves were located, as far as the ports and the combustion chamber and the exhaust, all that was everything that I could work with. So using all the stuff that I'd been taught by the best of the best for years, I applied, and it turned out to be a pretty good piece.
Now, are we talking about the Ram Air 5 stuff?
Yes.
So let's go into that. We already talked about the story kind of briefly, that actually John DeLorean's brother was at the drag strip, saw these cars that were running faster than most, went and looked at it, found out it had a tunnel port head, took the tunnel port head to John. John said, let's develop them. They developed a few of them, and then John moved to Chevrolet. And the who knows what happens to the history of those heads. Well, the Ram Air 5 head came back in an aftermarket component. And there's actually two of them. I didn't know that, but there was actually two of them. One was made by one company. It really wasn't a race head. And then what happened was Katterjohn got involved with this and developed the Ram Air 5 head. So I'll show you some pictures. You can kind of talk about it, which is pretty amazing when you see this. So there's the combustion chamber. How many cc's is that?
Right at 68.
Okay.
Because it has with the valves in it.
Yep.
That was the other thing that, again, I started with a casting that just had, two holes for where the ports were going to be. Everything was no bigger than probably a 50-cent piece, maybe that. But when I was tasked with this job, and this is what we wanted to do, I pretty much had a clean sheet of paper. And the other thing is, those particular castings right there was only so many of them available because they put a spacer in the core box, and they moved the intake and exhaust ports up an inch. And you can see along the outside edge, on the exhaust side, how thick that flange is compared to what they normally were. But this was for a specific engine, for a specific class,
Yep.
to do a specific job. And again, to look back and say, okay, in this particular weight break, we need to make this much horsepower at this much RPM. So I ended up with a 2,400 intake and a 1,680 exhaust. But that shape of that combustion chamber right there, is, to me, has always been the most effective as far as the mid-lift flow, the scavenge on the exhaust side, where the spark plug is at.
Yeah.
I would have liked to move that's the spark plug hole hasn't really been drilled, but if you see the pilot hole right there, I moved it over closer to the exhaust and changed the angle on it because, again, I had a blank sheet of paper to do all this, but that's the end product. The prototype that was done on a damaged casting was then digitized and then was CNC ported. And again, for a race engine, the exhaust port to me was the big holdup. So I machined the cast on exhaust ports and made these bolt-on blocks that raised the roof up, that raised the floor up, because we know that they're going to be at a 45-degree angle sitting on the block. I also, part of this was the angle that was in it to get the headers to fit and all that. And then I also moved, there's no header bolt holes on there. The bolt holes you see are two of the fasteners that hold the block on. There's also two more to the inside. So I put them there so I could put the header bolts away from where the head studs stuck through. That was a problem on some of the other cylinder heads. And that was the calculated length that I came up with, using a predictive program. But the biggest thing was to raise the exit angle and lengthen the short side radius to be more efficient. That was, and then again, I came up with a 4 square inch intake port was what was needed for that size valve. And if you look at the castings, like the corner radius in the bottom, they're different because that was a mistake in the casting. The floor was too low compared to what we needed. And this was all answered when I finished those up and epoxied the floors in, and I put fairings behind the guide boss and then a vane on the other side of it to direct the mixture to a certain part of the area on the piston. Wow. But that's raised up. If you look and see how high that is, that probably got another ½ an inch of epoxy put in it. But again, the castings were already done and the flaws that were in the casting, and there were places where the metal wasn't hot enough, it didn't flow right, it was granulated. But on the initial casting that I did all the work to, I went in, since it wasn't going to see anything except oil from the CNC machine, I was able to epoxy that in for the prototype that was digitized, so it would have something to see and put the floor in the right place. A couple of these required welding because of the problem in the casting.
Okay. And
this was kind of a one-off deal. So when this was cast was like at the end of the day, and the crucibles had probably cooled off, whatever, and it told me that because it didn't fill in like it was supposed to. But like I said, that particular cylinder head is done for a particular size engine in a particular class. And again, I used all the stuff that I learned from the people that taught me what to look for. And since I had a blank sheet of paper, that's what I went for. And raised runner, to me, raised runner intake, raised runner exhaust, if you can use it, unless you're stopped by some particular measurement, whatever, the higher you can get them, the better that you are. But it all comes back to your calculated length for RPM range, for the airspeed, the kind of horsepower that you're going to make, also has a lot to do with that too. again, having a blank sheet of paper, it worked out pretty well.
Now they're on about a 400 cubic inch engine. Is that what they were made for?
Yes, both of the engines are in the 400 cubic inch range. They're on a 400 bore, 400 stroke, short rod, short deck. The decks were cut from, I think they were 10-inch 24 or 10-inch 240, and the aftermarket blocks were cut down to about 9.3.
Wow. How much power do they make?
Pardon me?
How much power did that engine make?
Well, that still remains to be seen. There's one getting ready to go to the dyno here pretty soon, but I knew that we had to be at least in the 1150 range to be able to run far enough other than the index and, be able to qualify, because the other cars in that particular class, they're 400 cubic inches, but they're pro stock truck blocks, they're pro stock truck heads. Again, there's nothing out there that has been worked as much as anything in the pro stock and comp eliminator, because you have a free hand to do pretty much what you want to do within the confines of what your engine really needs and where you intend to work it in the RPM range and where the torque into horsepower crossover is at. That determines a lot of what you're going to do.
I was looking it through here, and I have to put this up. So Joel says, hey, they didn't have a CNC in prison. Kenny learned how to use from books in prison. He said that he had nothing to do but had time on his hands while he was there. Basically.
That's probably so. That's probably so.
Now, Andrew Smith, he said this a couple times, so I better put it up there. And I don't know if we had mentioned it or not, but I think it's an important point. We had talked about merge collectors, putting them on. And you said it seems to be that they help most combinations. Does it help the guy that doesn't have step headers? It probably would help. Is it going to change the carb setup?
Sure.
And that's what he's making a point, because he said it twice to make sure that we say this, that it does change the signal to the carb. So you got to rejet.
Oh yeah, because any time that you change anything on the intake or the exhaust and you're trying to maintain your fuel air ratio, any time that you start scavenging better, you're making the engine leaner. You're pulling it out of there faster. So it's going to pull more in, and you're changing the volume of out, in and out. So anytime that you pull more out, you've got to richen them up, because they over scavenge will make them lean. And if they're lean, then they don't make power and they blow holes in pistons and burning off the end of spark plugs and things like that. But yeah, again, the merge collectors really shine in vehicles that use a lot of fuel, like alcohol, or in the different weather conditions when the humidity and barometric pressure come into it. All of it. There's nothing unimportant in a race engine, in any engine, from the top of the induction to the end of the exhaust. Everything in between has to work together. There's no unimportant parts. There's no detail that doesn't have to be looked at, worked with. And again, everything we do is application specific to the parameters of where it's going to work.
Elena, my daughter, says hi. Girl, you better be listening to this, because this is stuff that you're going to need to know when you start racing. So pay attention, girl. Good to see you. So George Dreich says, Larry Lombardo had foundry connections that let him rub small block Chevy head cores and went to Jenkins. Later became the 292 turbo heads.
Yep, and that started out as a 492. It was still an angle plug, but the 292 turbo heads were actually developed for Indy cars.
So that's true. He went to the foundry and rubbed the cores.
Well, they did, but again, it's bigger intake ports, bigger exhaust ports, more room to work with is what that was about. But again, back when all the factories, GM, Mopar, Ford, all of them, they had a big interest in what was going on at the racetracks. So, just like Warren Johnson. I mean, Warren Johnson had stuff done in industry, that wasn't related to vehicles. And, he had his specific things that he wanted done that the normal factory foundries wouldn't do or couldn't do. When this country was shut down for 2 years, a lot of things changed in the racing industry, and not necessarily for the good. A lot of businesses got hurt again. So racers that are committed, especially when you work for a particular brand and you're working towards a particular goal, you've got to be resourceful. You can't know enough people and have enough connections at any one time, because the plan changes all the time. It's like the old saying, when the paradigm goes to zero, everything changes. The people that are in the lead are the ones that think the most, that experiment the most, that have the what if attitude. Well, what if we change this? Well, what if we do this better? And in the racing industry, which is 180 degrees from what the manufacturing does, because the manufacturing was being dictated by the EPA. Look what happened to DART. And, the EPA hurt a lot of stuff, because to the common, ordinary, everyday person that doesn't like racing, that isn't involved in racing, that doesn't know anything about it, all they want to do is be able to get in their vehicle, push the button, it starts, they get to work, they buy gas, back when they had all the checking stations and everything, and to be able to pass that. All the repair shops that were burdened with being able to make these, you can't change this, PCV valve has to work, you can't do anything with the exhaust, all of it had to pass the sniffer. And, there was even times in racing where the fuel came into question, and, you're the biggest polluters of all. No, not anywhere close. But again, the old saying, lean is mean, if you can afford the parts, because if you miss that very much, you're going to hurt something.
Lean is mean and rich is a bitch.
Oh, tell me.
Now this is kind of interesting. You probably be able to answer this without an issue. Bruce says, how far have you milled the angle of the deck?
Well, generally, I didn't change the angle very much. I mean, I know there were some people that did, but we cut the decks down shorter and did most of the valve angle change, in the cylinder heads. But I know of guys that roll the decks over quite a bit and changed them, because, the Pontiac is a 14-degree valve angle.
Yeah, okay.
And again, all the factory stuff was made for everyday drivers. Sure, they could make horsepower and all that, but and there were 421s, I think it was, that did have forged steel cranks, good forged steel cranks, and they were available as blob cranks, just like when Chevrolet had blob cranks. The engine that you showed the cylinder head to, the crank then in it was a Pontiac raw forging high alloy steel crank, which were about like hen's teeth, because of aftermarket manufacturers. They didn't have much to do with Pontiacs. Scat does. There's been several, and you can get stroker cranks, but trying to get a de-stroked crank,
right,
and the counterweight's in the right place, and how aerodynamic the counterweights are, and the oiling systems that it need to have to turn the kind of RPM that thing's going to work in. it was easier just to start with a blank and a blob. Plus, they also moved the thrust bearing to LS. They used LS bearings and LS thrust bearing. So you had to start with a blank crank to be able to do that.
Got it.
And it's all about longevity.
Okay. Jeff says, what does Richard think about the modern ability to collect and review data in the world we live in? And then he says, in an individual basis.
Well,
meaning like a race pack,
Oh, yeah, absolutely. Absolutely. The more you can see, the more the data that you record, the better changes you can make because you actually have data to work with. And in the engines that we build anymore that are always on the ragged edge, especially in fuel air mixture and timing and all that, you don't have to go very far. You can look at cylinder pressure, you can look at EGT, where used to we could only read the spark plugs. I mean, that's still a pretty good indicator of where it's at. But if you miss that tune-up too far, and the amount of data gathering that we can do, the number of channels, I mean, it is amazing. So again, the more data you have, the smarter you can be, the wiser you can make the choice, and especially when you're right on the ragged edge with where, if you're too lean, you're going to blow a hole in something or burn something. And if you're too rich, you're going to wash the cylinder walls down. The other part is like in the compression where it's at, in the cam opening, you open it too soon and you put too much fuel on top of that piston. Now it's going to be in a hydraulic situation and be hard. You couldn't light it. It's too rich. There's again, and you can go back and look at your fuel air ratio, or like I used to take my little periscope, stick it in the spark plug hole, look at the top of the piston, see what the burn looked like, give me a better idea of where the timing ought to be. Look at the bend in the ground electrode to tell you where the timing's at. If it's slower, it's going towards one way. If it's faster, it's going out the other way. But right there on that bend is where I have found with race gas, yep, in the type of high compression, high RPM stuff, if it's in that bend, you're really, really close. And you've got to read what's on the porcelain and the bottom of the porcelain to go along with that. If it's bleach white and got little black spots on it, you're going to be in trouble because the little black spots are part of your piston.
Yeah, definitely. CD says, I'm not sure what he's saying. You can back cut the exhaust side and plate it to aim the air straighter.
Oh, I'm sure you probably can.
So there you go.
Are you talking the backside of the exhaust valve?
That I can't say. Add more to the question because I see you've typed some questions.
Okay, but yes, you can back cut the exhaust side on the valve.
Yep.
Oh, and plate to aim the air straighter. Yes, you can. Yes, you can.
David Reed said, Brodix cast a lot of heads for GM, whatever the name was on them. Okay.
Oh, all the Pontiac stuff came out of Brodix when Tonawanda shut down up in Tonawanda, New York, where all the bow tie heads and 18-degree heads and blocks and everything else came from. There were other foundries that stepped in, and I mean, everybody probably knows the story that Dick Maskin and Gary St. Dennis and a few others went in and bought the core boxes, bought railroad cars of ore, just like GM used, and then Dart built the new building a couple miles down the road from their original building to be able to do that. But yeah, I don't know of any Pontiac head in the GM line that wasn't done at Brodix, because they had the bandwidth to be able to do what GM wanted. And, you know, you're not, when you start talking about Brodex, you're talking about somebody that's been casting cylinder heads for how many years. They probably have the best alloy that anybody has. And you talk about the best repairable alloy, and their heat treat is good. I haven't seen too many GM heads as far as the Pontiac goes that came out of Brodex that wasn't an excellent piece. Even the raw cylinder heads we got that only had locator holes in them and things like that took a lot. But again, that was to be welded, worked, and sent back to core box being made. You can't beat JV and the boys. You simply can't. Now,
and Andrew says they were 427 castings and 386 and 388 castings were the forerunner to the Big Chief and Big Duke heads.
No, they are Big Chief and Big Duke heads. But in Pontiac, that was the casting numbers that they had for the different valve angles.
Okay.
Yeah, the 427 Pontiac head was also called a Big Chief, and then the other two, which have different valve angles and combustion chambers, were also part of the Big Duke.
Okay. Now this guy says BP, Big B Port 97. DCI and Lynn and Stacy did 5 heads.
They have a Ram Air 5 street head.
Okay.
There's been plenty of their Ram Air 5 street heads turned into race heads, I know for a fact. And, you know, DCI, I'm not familiar with this stuff. I know who it is. But Lynn and Stacy's stuff has the correct valve spacing, round intake ports. They have the exhaust ports in the right place.
Okay. Now, do they have the push rod tube?
Yes, all of the Ram Air 5s, just like from factory, have the push rod tube through the middle of the intake port.
Now, did yours have that?
Yes, it did, and we started out in the R&D using an oval brass tube.
Okay.
And then for the race heads, we had a tube extruded that looked like an airplane wing, where it had a splitter vane on one end and rounded on the other, but it still looked like an airplane wing.
Okay.
The only difference, an airplane wing is flat on the bottom, you know. So this was rounded on either edge, so we could direct the flow. And I can tell you for a fact, I started out with round, went to oval, and the splitter vane was the way to go in the race heads. So that's the one big difference if you buy a Ram Air head from Ram Air 5, which is Lynn and Stacy, is what port work gets done, what the combustion chamber looks like. They all have pretty much the same valve size. And then only the race heads get the airplane wing or the aerodynamic tube, even though I know of several sets of street heads that were competition ported, airplane wing, brass tube in them, and all that. And I'm thinking, you know, for where these are going and what they're going to do, you know, man, that's smashing ants with a mallet. That's such overkill. But again, I have the most experience with the Ram Air 5s that Lynn and Stacy did.
Okay. Charles said, when looking at those pictures, good looking chambers and exhaust ports.
Thank you, Charlie.
And then Bruce, we already answered this. That's what we were talking about. He called it the tree trunk in the middle of the port. So thank you for that.
No, there's no such thing.
Thanks, Benj. Crouchy.
Oh, yeah.
He's from Australia. You know
I know.
who he is. Yep. Hey, Tim and Richard. Hi from Australia. Hope you guys are doing well. We sure are. Thank you for sharing your time and knowledge, Richard. Yes, thank you, Richard. Appreciate that.
I'm just,
we got 80 people here, and we've had up to like 90. We're at 2 hours and 24 minutes. It's like every live chat on DragBoss Garage is like 3 hours long. That's just how it works out.
That's fine. I mean, you have several pictures. There's people that have questions, and anybody going away without their question being answered, if I can answer it.
There it is. If you don't, you say, I don't know.
Well, simple. I can say I don't know a lot.
My buddy Steve says, is Richard saying that the port floor height is dictated by RPM?
Are we talking intake or exhaust?
Good question.
Because
put it down there, Steve.
Both of them gain from having the port floor raised, because if you left the port floor in the same place and you raised the roof, now you're affecting what happens on the short side radius and the amount of velocity that in and out. And again, the reason that we raise them is what it does for the short side radius. And it also, the short side radius is affected by the back wall of the bowl and how straight up and down it is, just like the short side radius is controlled, again, by what it's going to do and the amount of angle that we use in there. And the percentage in the corners of the short side radius dictate a lot of what happens, because we want, whether it's going in or out, we want it to stick to that short side radius enough to bend it without separation. We don't have that problem on the exhaust side, but the exhaust side is all about speed, where the difference in the port floor and the roof and the intake makes more difference than what it's doing, because one is being affected by delta P, where the other is got 1,300 pounds of exhaust pushing it out, but we still have to get it out where it fills the entire port side to side, top to bottom, and especially on the intake side, and keep the turbulence out, especially in the port, until it exits past the seat ring into the combustion chamber area. And that's a lot controlled by exactly what you're doing, whether it's a flat top or it's a dome, where the spark plug is at. All these factors have a different effect on what it is that you're going for. And yes, as you raise the runner up, you're making the bowl area in the combustion chamber farther away from the roof. So yeah, it's getting bigger, and that is part of turning more RPM, is more available fuel and air to work with, and being able to exhaust it and get it out so you can pull more fuel and air in. That's why raised runner heads make a lot more horsepower. And just like the heads that we do for the super stock cars, every one of them, we're raising that floor up to get up to the roof, again, because you're limited by the amount of cc's that you have. You have to make it in valve size. You have to make it as effective as possible, because the whole goal is horsepower and repeatability. So sometimes there's a real fine line that you have to walk, because the other side of that is tunability. Because if you have a cylinder head that is not proper on the intake and the exhaust side, now you're trying to tune your fueling system. How much timing does it need? What does the valve lash do? Does it over scavenge? Does the fuel fall out of suspension? All these things have to work, and all of it is dictated by shape, length, height, and valve angles, valve shape. And every one of them is different. Now, if you're doing the same thing like NASCAR it's all cookie cutter. It all, once you find out what the combination is, even though all of the ongoing R&D, if it's not tested, if it's not raced, then you don't know for sure. Yeah, the dyno will tell you a lot, but the dyno is not affected by downforce or how aerodynamic you are or whatever influencing factors, the angle of the windshield. All of this determines on the down pressure, which you still have to accelerate the car. You still have to stick it to the ground, and that all comes back in for your torque and horsepower curve cross, RPMs that you can turn. Anytime that you're limited in RPM by, say, a sanctioning body, then that's the corridor that you have to work within. And wherever it's at, you want to hit peak horsepower right as you hit the rev limiter. I tell the guys with the sprint cars and the dirt track cars, I said, you want to hit almost maximum RPM when you stick your nose in the corner, but you have to have enough to carry yourself through the corner and accelerate out the other side. And if you do that with gear and run out of RPM before you get there, now you're doing is bouncing off the rev limiter and not getting where you need to go.
Thanks, Steve. Bport 97 says, with the characteristics of the Pontiac, I made more power with the conventional Ram Air 4 exhaust port. The back pressure worked better on track.
Okay, in what RPM and what cubic inch and what RPM range?
Throw it down, and we'll be back. Now, number 141 body. He says, I've known Rick for 50 years. He is very sharp and an innovator.
Again, I'm a product of all the people that I learned from. And again, I can't thank all those people enough. And I know there's several of them on here. And
oh yeah,
thank you.
We appreciate that. Number 141. That must be his race number or something. How about this one? 2 green feet. Back cut exhaust valves sometimes have negative gains due to reversion.
I have not seen that in the areas that I've worked in, and that may be true in lower RPM, but reversion, that's another reason we have step headers. That's another reason that we have merge collectors and exhaust port plates, because we know at overlap there's going to be some. And I have not seen problems with back cuts doing that. It would depend on the port. It depends on the RPM range.
So this is interesting. We'll find it out. I have an inside story about the repairable alloy. So we'll wait and see what that is.
Adger always has interesting stories, let me tell you.
He does. I can't wait to get him on. So thanks, Adger. We'll see you in a little while. We got to figure that out. How about this? Mike. Hello, Katterjohn. There you go. Do you know Mike?
I probably don't. I know a lot of Mikes, but
Mike FL2TX, something maybe Texas, Florida to Texas. That's what it is.
Oh, yeah. Okay, I know who that is. Thank you. Hello.
There it is. Don Dotterer, latest history about Richard. The latest history. So I guess what he's asking is, where are you right now? Are you still building engines? Are you still machining stuff? What's your plan?
Well, I have a plan to get back into this. I unfortunately had some tragedy in my life last year that changed where I'm at in life, and there's several different options. I will go back to what I've done for the last 53 years once I get some things taken care of and recover from some losses, personal losses. And yeah, my phone still works though.
There it is. Thank you. Appreciate that, Don. Here's an interesting question. Do you feel there's a compression ratio limit, say like an NHR comp eliminator engine?
Well, if you have, it all just depends. If you have too high a compression ratio and you start, let's say in the combustion chamber, and you start affecting how the air flows and the fuel air mixture and all that. But I would say that there's plenty of engines out there that are in the 16.7, 16.8 area. But yeah, you will get to a compression ratio limit that detonation will start taking over because of its inefficiency. You know, if you're going to run 17-to-1 plus, then you might as well start burning diesel fuel or alcohol.
Yeah.
But yeah, there's a limit where it starts making less power because you shroud the chamber, or the chamber is so small that, you know, moving the valves closer to the top of the pistons again has its advantages, but you can also get to the point where you can't get sufficient flow and sufficient scavenge. So yeah, that's and it comes back to, again, the best fuel out there. You squeeze it too tight and it detonates. Now we start hurting parts. You'll have to pull timing out. There's several things that may be detrimental to the overall combination. You know, it's, again, comes back to pro stock and some of the comp eliminator engines. That stuff's been tried up, down, everywhere there is to go. But we have to come back to the reality of fuel in, exhaust out, and cylinder pressure makes the horsepower. And whatever that combination is for the type of engine it is, you'll know, because it will tell you. It will tell you.
There you go, Bruce. Thank you. Now, AC says, Richard, tell us more about your first drag racing experience. How did it go?
Well, my first drag racing experience, when I took my 55 to Chandler, it was an AHRA track at the time. And their rules were a little bit different. But when I first started drag racing with that, the tech man puts you in a particular class, once they weighed you and knew how many cubic inches that you had, I think F hot rod was the class that I was in. A guy sent me a black and white picture of the 55 with, you know, the shoe polish on the windows and all that. But I ended up winning, and I still have that trophy. I think there was 6 cars that were in that, and it just worked out on that day that the track conditions and things like that worked out in my favor. I think the other 55 that was in there, I can't remember the combination, but all the cars were all, you know, multiple carburation, 4-speed stuff. Some of them had stock suspension. But that's how it turned out. And yeah, back in those days, it was all quarter mile, and used to every once in a while, at least 4 or 5 times a year, Chandler would have a 2-day modified meet, and it was nothing there but modified cars. And AHRA used to do that. NHRA, the track owner would do it, but the NHRA people would come down the tech director, the tech inspectors, that were all pretty close, Bowling Green and places like that, and come down. And I can remember 1-2 day modified meet. We had 70 cars there.
Wow.
And none of them were slouches at all. I mean, that was back in the days when Bob Camp still had his Corvette, and the Red Bull boys that worked for them had their Camaros. I mean, there were cars from Wayne County. There was cars from probably 200, 300 miles away because, of the payout. But the main thing was back then is they had class, the winners class, all went into the main eliminator, and everybody had a good time. I mean, it was like any other race. It was who tuned the best and who tuned to the track conditions, even though they changed from 8 o'clock in the morning till 10 or 11 o'clock at night. Who did the best job of tuning and driving. It was because back then, I mean, everybody still had cast iron cylinder heads and, the old style tunnel rims and out of the box carburetors. And if you either had a Super T10 or you had a Muncie, and everybody ground every other synchronizer tooth off and all that. But, everybody came to race, and it was really, really good times. It was, I mean, anymore, it's about cubic dollars, not cubic inches.
Mm-hmm.
And it hurts a lot of people. Now, there's a lot of grassroots racing that is coming back that they do. There's several tracks that have nothing but the modified cars or nothing but the stick shift cars, and they're growing. And now that NHRA has put modifieds back into competition eliminator, it gives the people that's how they like to compete, rather than giving somebody half the track length before they get to leave, in good class racing. And I think it'll start bringing back a lot of the cars back into comp eliminator, and which to me, I think is great.
If you could go back, let's say you could go back to any time period, obviously we're not talking about 1500s, we're talking about racing time. Where would you like to go back, and what 70s, the later 60s?
Actually, if I was going to go back, I would probably go back to 1992 and start there and go forward again, knowing what I know now.
Oh, yeah. Yeah.
Yeah, I really would, because, the 70s to the 80s, there was a lot of innovation going on.
Mm-hmm.
But the 80s to the 90s is when people really started working with cylinder heads and combinations, and the cars were built a lot safer. And, again, safety was always a concern, but sometimes it wasn't addressed to the point that it should have been. And there's also overkill on that, because it starts any time that you start hindering the drivers for, let's just say, the rules, then you're going to take people out of racing. And a lot of the sanctioning bodies that are coming back now, they're going to keep everybody safe, but they're not going to go on overkill. And the cars are so much safer now. Mm-hmm. They're so much better constructed. You don't see, with certified chassis, you don't see people that can't weld, chromoly.
Mm-hmm.
People that can't weld DOM, even though it's allowable, that doesn't mean that it's what it should be. To me, TIG has always been the way to go.
Right.
I've been doing that since as far back as I can remember, and it's so controllable. If you have the right cup, the right tungsten, the right shield gas, hydrogen embrittlement is almost non-existent anymore. And to be able to weld all the exotic metal that we can weld now, it's safety is always first. It's always the consideration, and a lot of the rules anymore, especially about construction and safety equipment. Every race that you finish is another one that you can go back home, go do what you're going to do. And I've seen some really horrific crashes in the last couple of years because the amount of horsepower overran what the chassis was, or a particular component failed that you wouldn't have thought would have failed. But when you overstep the limits of the tensile strength, of the malleability, all you're doing is asking for trouble. Going fast and crashing is not the point.
That's it, man. I get it. Let's see. Oh, yeah. Now I saw, that's all right, man. Darian Houston. Good evening, guys. I'm sorry I had internet issues. No worry. I see him on Facebook a lot, so it's not a big deal. It's on for a replay. You can replay that when you want, so don't worry about that. Glad you're here.
Yep.
He said, just to brag on Mr. Katterjohn a little, the man has been a huge inspiration and help to my program and my friends' programs. A wealth of knowledge. So cool seeing you on my TV tonight. Very nice.
I'm more than glad to help you. You've been friends with John Bowman for a long time. You've been friends with a lot of people that I know. And this may be the information age, but so much stuff is so closely guarded. And if you're going to race, you want to race because you want to enjoy it. Struggling at anything sucks. So if I can help you with one little small problem and point you in the right direction, I am more than glad to.
Thank you. Carly Wolf Racing. She donated $5. Thank you, Carly Wolf. She said, have you heard of the 18-degree Big Chief Pontiac heads running alcohol? Also, have you seen the Visner Pontiac heads?
I haven't seen enough of the Visner Pontiac heads to make any kind of a judgment, but yes, the 18-degree Big Chief Pontiac, the 427 casting, that was run with fuel injection many times. And as big as they are, the cross-sectional area and the short side radius that's in that on the intake and exhaust side both should handle alcohol without any trouble whatsoever. But like I said, unless it needs to be on a big cubic inch engine. If it's a smaller cubic inch engine, then it really needs to turn the RPM. And a volume fuel like alcohol, you better squeeze it up pretty tight.
What do you mean cubic? How big is? Give me a number, cubic inch, so we can relate it.
Well,
632.
Those were originally made for 500 cubic inch, 9,500 RPM, 2,300 pound cars with a manual transmission behind them.
Okay.
And I know of people that have those heads that are down in the we'll say 500, 540 region and don't turn but 7,000 RPM, and they've got twin dominators on it and a fully ported manifold on top of a big set of heads, and there's no airspeed, there's no throttle response, and it's a detriment. Now, the bigger the cylinder head is, the more cubic inches or the more RPM
baby,
that you have to be able to have the airspeed. Again, airspeed is throttle response, it's torque, it's recovery from the launch, it's recovery on the gear change, because once you fall down out of your torque range, power range, it will struggle. It won't recover. The fuel falls out of suspension. It drowns the spark plugs. You know, there's so many things that happen. Every engine combination that you use, it has to start at the top of the induction system and end at the headers and be capable of what you want. I know of 600 cubic inch engines that have those heads that were ported back in the pro stock days, and they turn 6,000 or 7,000 RPM and run just fine. And what those were made for. It also depends on who ported them and what they were ported for.
Yeah.
And that head out of the box won't work. You know, there's a lot of work that needs to be done on them to get them where they need to be. And again, it comes back to the cubic inch and RPM and what your air demand is. And again, there's a lot of predictive programs that will tell you a lot about what you need, but I haven't ever seen a set of those that didn't require quite a bit of porting. And that's why they were raw castings to start with. And if they've been professionally ported and, you know, you've got big enough valves and big enough ports, you either need the cubic inch or the RPM, one of the two.
What RPM are we looking at? 995 and up?
Well, again, you have to look at back what the original intent was. But with the camshafts and stuff that we have now, you know, and the intake manifolds and all that, but I'd have to know how much air those heads flowed. You know, I'd have to know what camshaft, what valve size, what weight of the car, manual, automatic, rear gear. There are so many things that you have to look at. There's no way to give a prediction other that is a big set of cylinder heads made to turn a lot of RPM. Again, the alcohol helps out in the size because of the volume required. So if I had a little bit more information, I could probably make a better recommendation. But again, those are really good heads. If you will look, let's say in the Brodex catalog, and look at their 18-degree Big Chief head and look at their recommendations of what they say for cubic inch and RPM and all that, or you can call Brodex and talk to one of the technicians, and they can tell you more about that because you will know more about your combination. That's another thing. All these manufacturers of camshafts and cylinder heads and manifolds and different engine builders, they're, again, a wealth of knowledge because they're not going to steer you wrong.
Mm-hmm.
You know, just like me, I want everybody to be successful. I want everybody to win. I want everybody to be safe. But all those decisions that you make to get there is on you. But technical information, there's a lot of it out there, and it's there for you to use. Use it. Again, knowledge is power. Be the most powerful.
Thanks, Carly Wolf. Appreciate that. Thanks, AC. Thanks for sharing, Richard. Joel says, hey, great job. Thank you for being here. We're glad you were here.
I'm flattered, but you've known me a long time and you helped me a lot to get to this point.
Doctor's in the house and he says, listen, many, many variables, as he says. Cylinder head is a science and is amazing.
It is. It's physics, chemistry. There's so much that goes into it, you know.
Thanks, Doc.
Yes.
Mike, Florida to Texas says, Darian, I agree. It's helped me a lot, and I'm just learning in my house garage. Always has time to talk and answer questions.
Yeah.
Charles says, great to see you here, Richard. Thank you, Charles. We appreciate you being here. We're at 3 hours. I think we're going to call it quits for now. You know, and listening to these questions and listening and the conversations that you and I had, Richard, you know, it's almost a thing that I was thinking, you know, of a service maybe. I don't know if you're into it. We'll talk after the show. but we could always have a consultation service where guys fill out an information sheet for their combination. You work with it from your experience of 53 years, plus whatever programs you have, which I know you have a bunch of information. And I mean, you could steer someone in the right position and save them a lot of money for the cost of a consultation fee. So that's something to think about.
It is, and it allows, it's another avenue to be able to put experience and education to work, you know, and helping somebody is a great thing. Again, I pay it forward for all the people that helped me all these years.
Thank you. I appreciate that. We've got a couple other guys that are saying thanks. Thank you, Jeff. We appreciate you being here. Bruce, thank you for being here. Also at U2AC, thank you. We're going to end the stream now, so let me get over here and push the button. And we're saying we're gone, guys. Like I always tell you, you're always seeing and learning something new at DragBoss Garage. So
Absolutely.